1, 2. Perfect. Bun. Hi everyone. Nice to see you. Okay, we have some echo here. Okay, welcome to our TSM launch. It is a nice edition of 1, 2, 3. Today we'll talk about automotive. Still we'll have another launch event in 2 days on Agile, just to let you know, but that will be only online. So today we'll talk about automotive, and I hope you like the cover. It's been some work. And today we'll start with an open word from Jans from Bosch. Then we'll continue with Cătălin Golban. He will actually show us a live demo. Then we will have a presentation about machine learning. What's the difference between machine learning and engineer and a classical software engineer, and why we, as most of us as a classical software engineer, need to learn also some math in order to switch to machine learning. Then we'll continue with Max about smart trams, and we'll see how the automotive industry is applied to trams and trains. And then we will continue with a presentation from, where is it? Well, we'll have another presentation from PTech, remote. I hope that will work. We'll see. And then I'll talk to you about this edition of IT Days. And at the end, we'll finish with a nice discussion on automotive and what's happening locally here. So mainly this is the agenda. Thank you to our partners. And we'll switch now to Jans. Just a second to see if it's working.
Hello everyone. I would like to give you a warm welcome to the Engineering Center Cluj today. It's a real pleasure for us to host the launch of the Today Software magazine every year. And today, at least for the first time since I'm here, also with some live crowd. That's really cool that we are away from the pure online events. I would like to give you some quick facts about what is your host and host organization this evening. So my name is Jens Klemm. I'm in the engineering center here responsible for automotive steering. And the Bosch Group itself is a global supplier of technology and services. We have more than 400,000 employees worldwide, around 80 billion euros turnover, and we are represented in more than 60 countries. Technology like a Bosch, so we tell as a slogan that our products are invented for life. That means in everything what we do, we aim to globally improve the quality of life. So we want to generate some purpose with what we do. In this respect, AIoT is becoming a game changer for us. So usually people don't associate that with Bosch because it's a very traditional company, but actually we are already one of the very big players. By 2025, all of our products will be either containing AI or will be developed or manufactured with the help of AI. Bosch in general has 4 big sectors. We have the mobility sector, we have the energy and building technology, we have the consumer goods, and we have the industrial technology. Here in the engineering center, we are mostly focusing on the mobility solutions. We like to say we collaborate to shape a new era of mobility, which is sustainable, safe, and exciting. So what does that mean? Sustainable, we are going more and more away from all combustion engines. So carbon neutrality is a big, the biggest topic I think all of you know. The future goes towards battery electric vehicles, but in Bosch we also think that fuel cell and hydrogen-powered vehicles still have a big future. Reason for that is I think everyone knows the standard problems of the battery with range and weight and whatever. And with fuel cell vehicles, we will be able to overcome these problems and also be able to extend to a very long driving range while still being locally carbon neutral. And that's why, so to say, an opposite to the little bit global trend and political trend, Bosch is still investigating a lot in that direction. That about sustainable, then safe. So the future very clearly is a software-defined vehicle. So some even tell it goes in the direction of a smartphone on wheels. So we will have more and more features which can be booked after you purchase a vehicle. It will be everything more and more connected. But for us as automotive engineers, it's still a way bigger challenge than for a smartphone developer, because we still, of course, even though the release cycles become shorter and shorter, we still have to fully adhere to all the automotive quality standards, and we have to make sure that our products are safe when they reach the customer. And then, of course, exciting, so there you will see some demonstration later by my colleagues. It should not just be sustainable and safe, but also be exciting for our customers. Now to the engineering center here in Cluj. It got founded in 2013 and since then has steadily increased its development activities. We have seen a tremendous growth in size, but also with an impressive competence build-up. We have in the meantime a vast expertise in software, hardware, mechanical and reliability engineering, and with that we contribute to the development of excellent products in our worldwide development network to, so to say, for our main topics, electrified, automated and connected mobilities. We will see some about that later. We are really here in Cluj an integral part of the international development network. Just to give you some examples on that from my area. So this year I already had 2 guys from Germany assigned for several months here in Cluj working with the team. My entire team is practically working in big international projects. Right now 10 guys are in business trip in Germany, visiting some conference about testing and virtualization together with their German colleagues. And even in another 2 weeks I'm expecting 2 short-term assignments from Vietnam, who will pick up some topic about virtualization here with us and then take it back to Vietnam to be able to support our projects there directly from the region. About the engineering center, what is also special is that we have many different Bosch business units here under one roof. So I'm responsible for steering. We have the Bosch engineering group, Max will show later. We have powertrain solutions here with several departments. We have cross-domain computing, so Cătălin will show you something about that later. And we have this here all under the same roof with a very close proximity. That means some things are even for us easier to achieve here in gaining synergies than it's for our headquarters in Germany, because there traditionally the the business units are grown in different regions and different locations and are not interacting that closely with each other. We have here also in Cluj really full project responsibilities and all component responsibilities, so there is a lot of interesting stuff to do. We have currently over 1,200 engineers here in the location, but still a big growth target in front of us. And we are also openly, we are struggling a bit to keep finding the real qualified people which are willing to take full ownership and which are willing to go the extra mile together with us in these projects. That's why we are now also expanding to other locations in Romania. So in October 21, we opened the dependance in Bucharest, and this was quite successful. We started finding some good people there, and that's why we are currently investigating in spreading inside Romania to even more locations. And so the top priority we have on our list right now are Iași and Sibiu. According to the Catalyst study, Bosch for years now is the most desirable employer in Cluj among engineers, and I guess with what I told before, that's quite easily to understand. And if you look our building, this is also something really no one has here. We can be proud of that and can be happy to work here. We try also to keep a very close connection and good relationship to the universities. So of course in Cluj to the Technical University and the Babeș-Bolyai, we are offering 3 master courses, and we have four different seminars for bachelors. We have projects for doctoral students, and we also have several research projects or research cooperations with the universities in Cluj, as well as now outside. We have with the Polytechnica in Bucharest, and we have with the Technical University of Iași our first projects together. Also, we try to, let's say, prepare young engineers or students who are about to become engineers as best as possible for what real life and real working means. So each summer we are having a working student program with more than 200 participants, which we during the summer integrate really in real projects and let them experience what does automotive development mean. And this is also here inside Cluj a good source of recruiting for us then to take the best out of them. Now, with respect to the current TSM edition, we will see 3 really exciting articles written and presented by my colleagues. I think Ovidiu already told us the agenda, so I'll skip that part and I'll offer the stage to Kata, who has the first presentation about the computer vision and automated driving, and including a really cool live demo. Thanks for your participation and thanks for coming to us this evening, and I hope you will really enjoy the presentations we have.
Okay, and just before our next speaker, I just wanted to let you know that we will have a live demo from a driving car, as far as I understood. So there will be some connections and stuff there. And let me see if we have the intro. Yeah.
Okay, so yeah. Hello everyone.
Great. So we'll do the demo first.
we do the demo first. So my plan was to say, look, we have a movie here, I show you the movie, and by the way, it was a demo, it's live from Cluj, but many people already destroyed my plans for today evening. So I'm now in contact with my colleagues. Guys, I hope that you can hear me. And
Yes, you can hear us also?
I mean, I can hear you, the others don't hear you that loud, so just start, and I will then explain what they show. We start with a light demo, then I will also have some quick slides. Ovidiu, if you tell me how many minutes I have to move eventually
it's fine,
quicker.
It's fine. So far it's fine.
I will tell you a secret. I presented those slides several times, one including this week, and then I already practiced to do it faster.
Okay,
Good.
perfect.
So, Gabi, please, you can share and you can start. So, mainly the guys are somewhere, I don't know exactly why, but should be close to the building here. And they have a car equipped with many sensors. Actually, I think you know this Jaguar that we have now for many years, and actually we believe that we need to change it already. And this is equipped with sensors, video sensors, radars, LiDAR, and the team is doing a lot of video perception, and this is what we plan to show you. Let me move back and see if we have. Yes. So we can see what you have. So what you see here is 3D perception based on a single video camera showing some height over ground 3D measurements on Paris Street, if I see correctly here. And basically here it's a point cloud around the car. It's kind of composed in time, so from what it sees in front, it's reconstructed and then aggregated for several frames. Guys, if you move to our next demo, so then we see some AI in action. Road markings, curbstones, cars, and so on. By composing this AI stuff together with what we've seen as 3D before, we do something called free space, drivable space, so mainly detecting the free area in front of the car where we can safely drive and guide purely based on video, 3D, and of course in an automated driving setup it would work together with other sensors. No wheel automatically, actually by law we would not allow to do so, even if we would want to. It's a gateway in between this kind of system and the control of the car. We are working actually with the government to do some legislation on that, and it's going quite well. I think there is a draft which is in public debate, I think that's the English word, and hopefully it will be soon out there, and then we can test automated driving systems outside on the roads under some conditions which we are carefully discussing so that it's fully safe, and that's on the way. Yeah, so maybe next year or in 2 years from now we will also show some steering automatically happening on the road. Gabi, if you switch now to free space stuff so that so we've seen the 3D part before. We have this AI-based segmentation. By fusing them together, we do something called drivable space, which, as opposed to what we have seen before, this is 3D. So this is 3D information in front of the car. You see these distances, left, right, how big is the corridor, if you can drive through, and so on. This is not like latest and greatest and newest technology. This is some things that colleagues were working some years before. And on top of this, actually, I want to build my quick information today, and you can find more information in the article about what we are doing now, where everything is going, what are the trends, and what happens actually when doing automated driving perception technology development. No, no, actually, I would expect that it's still here. Yeah, they are still here. Guys, thanks a lot. Colleagues are already impressed here. Many rounds. They look forward to see you to different conferences, maybe to IT days with Ovidiu, and to also come in the car with you, not only watching it on the screen. Okay, so now I will switch then to my actual presentation, which it's about current trends in automated driving perception, technology development. So perception is what we've seen before, understanding what's from the video, what's in front of the car, using 3D reconstruction methods, using AI and deep learning and so on. And why we do this? We do this because we want to have self-driving cars. Self-driving cars, it's a fuzzy word, let's say, so it's mainly cars that have a system which control the car and replace some of the actions of the driver. Industry is now putting a lot of efforts into moving from driver responsibility, so you can have self-driving cars where the driver needs to pay attention, and system responsibility, where the system, like the ones that we have seen, is fully responsible to guide the car independent of what's outside there. And this is what we are working on. I don't enter into more details. And yeah, we see some trends that are happening. So on one side, we see that we move from single sensor systems, as we call it, or single camera systems to multi-camera systems. So we will not have like one single camera, but we need to process the information from up to 10, 12, depending on the system configurations, cameras around the car. And that's a lot if we think of bandwidths that are flowing from the cameras to some central ECU. We see that there is a lot of technology to be developed there. For example, the colleagues here in Engineering Center Cluj, you know, PCI Express, this bus from for communicating with graphic cards. They are using this kind of technology to stream data between the ECUs. Then a second trend is to move towards this kind of central ECUs that I was mentioning. So having cameras, sending data to a central ECU, vehicle computer we call it sometimes. So it's AI-enabled, high computing power device that can process all this amount of information from the sensors in order to realize automated driving. It's not only cameras, it's radars, by the way, and we have activities in the radar development, radar technology development. This is really interesting from both application and signal processing point of view. Third trend, it's increased use of artificial intelligence. Lucian will have later a talk about this. So what means to move as a software developer from, for example, from writing pure software code to writing some code that parts is software, part is a neural network that needs to do the work that some piece of code used to do it in the past. And the last and quite important one, it's the fact that we have more and more software-defined vehicles. So the cars today have more and more software. Some estimations show that one car today that is like released and produced today have more than 1 million of line of code, like code compiled to build firmwares for different ECUs in that car, and this is increasing. So we see more and more software in the cars, more and more technology in the cars, and also something that could be surprising for people that do software out of the automotive industry, software updates over the air. So in the past, when you put some ECU in the car, you never change the software, should be rock solid stable, controlling the steering, controlling the powertrain, and so on. Now things are changing, at least for some domains, and driver assistance, it's one of the domains where we can have this kind of software updates. Why this is important? Because when having such neural networks that you were seeing before with red and yellow and whatever color for entities in the traffic, those have corner cases. And it's important to identify those corner cases in concrete traffic situations, to collect data about these corner cases, and then to retrain the neural networks and send software updates and do it again. So do this, what we call data loop, collect data with relevant scenarios, send it in the cloud, send it back to the ECU. On such a pattern, it's not only data collection, so more use cases are working on that, and there's a strong connectivity trend in all the automotive industry, like building precise maps, for example. So those are the trends for software community, some of the technologies, programming languages, frameworks, and so on that are behind, and it's much more. It's mainly quite hard to capture them in one single slide, but those are the most important ones. As conclusion, these 4 trends, so having more sensors, 360 degrees, vehicle computers, increased use of AI, and data loops to increase continuously the performance of the AI processing. That was from my side. Thanks a lot. And looking forward for the break afterwards. Please come with questions to me.
Thank you, Cătălin. I think it was a great presentation, and yeah, we are looking forward for the next 2 years to see what you are doing actually today. If you have any
got the point, yeah.
If you have any question from the audience, how much you are using machine learning versus classical programming?
It's hard to say, because we need to see, okay, what is the efforts, maybe 50-50. I don't know, lines of code you cannot compare, because one is neural networks, the other one it's code, yeah, lines of code. Mm-hmm. But it's more and more, so we need to quantify it somehow to say how much. But the thing is that more and more parts of the software stack are taken by this data-driven development. So instead of working on C++ code embedded to deal with sensor data, we do more and more code for data engineering, preparing data sets, cleaning data sets, selecting the right data, collecting the right data, and so on. So efforts move more and more towards data engineering and training neural networks and so on, and less and less on the embedded part. And not only on perception, also on situation interpretation, planning, fusion, and so on. So it's more than perception when we talk about automated vehicles.
Okay, I have more questions, but probably will be best to address them at the panel. But we have a question here.
Do you use any open source software for semantic segmentation you mentioned?
No.
Or the drivable space detection? Anything worth to mention, such as a playground for any of us to play if wanted?
Directly using open source, no, because we kind of do it on our own. We design the neural networks, we customize it for specific use cases and so on. We need to compress it in order to run efficiently on embedded hardware. But if we speak about open source is quite big. I mean, for example, we use training frameworks like PyTorch, TensorFlow, and so on. This is also open source. It's kind of tool for training stuff, and we are using that. Eventually, we have some add-ons on top in order to accommodate to this embedded specific part, but not open source that we take and we just reuse. That's not the case, because it needs the fine-tuning and adaptations to the embedded parts, to different neural engines that we are using, and so on. Same with free space, same with the other, with drivable space.
Okay, we have one more question. Oh, go on.
So also from my part a question regarding automated driving. You said that you were between level 2 and level 3. Is this the actual level or is it the level from 2 years ago?
Yeah, so to avoid confusion, demo was like some a bit older stuff because it would be hard from a confidentiality point of view to show the latest and greatest what we do today. Here it's more about trends and what we do today. And then to your question about level 2 to level 3, today, yes, we are working on doing level 2 to level 3 at scale, so not one single car, but having some maybe millions of such ECUs, like these vehicle computers here, that we supply to millions of cars worldwide, and that are working well also in this level 3 setting. Maybe initially, so it comes naturally, so initially it could be that it's more about the low speed, meaning traffic jam, moving from traffic jam assist, driver responsible, to traffic jam pilot, system responsible, and maybe later from highway assist to highway pilot, because high speed, higher risk, more redundancy and so on.
Okay, let's stop here with the questions then, and we can have more at the panel. Thank you, Cătălin. Okay, and now let's move to Lucian. Okay, Lucian, let me give you the... It's working.
Yep.
So, the stage is yours.
Okay, so hello everybody. I'm Lucian. I'm also part of Cătălin's department. I am responsible for more of the machine learning part, or actually the deep learning part. And today what I wanted to show you is how the machine learning development compares to a classical software development. And to start off, I want to actually show you why this matters now, actually. And I want to start off with how a day in the life looks like for any of us here. I see most of us are quite young, kind of the same generation, so probably a day in the life for us looks like we get up in the morning, we have our coffee, and we browse through a certain news feed or a certain social media platform where we get machine learning recommendations of articles that we want to read, products that we might or might not want to buy. They sometimes get a bit annoying, and so on, but you understand the picture. Then we go outside, we take our phone out, and we take a picture of, I don't know, let's say a nice flower that we saw, where after we take the picture, deep learning or machine learning algorithms enhance the picture with better colors and better contrast than the camera could ever take. Then we go to work and we drive our vehicle equipped with, like we just saw, Bosch state-of-the-art methods for automated driving. So the car brakes on its own, it steers on its own, and so on, of course using machine learning methods. So the idea that you've probably gotten by now is that machine learning is everywhere, it surrounds us. So it actually is a question now whether the classical software development is actually the same as machine learning development. So what in the past has just been writing code and writing software has now been transformed more or less or in large parts to machine learning, into machine learning. And to understand the differences, what we wanted to first do is, let's take a look at classical software development. Like, what defines it? What is it? And you can see we have here a picture of a guy coding, and to understand it, we thought, okay, let's try to explain what an ideal software developer is. What should he know? What should he do? What does he usually do? And we expect he needs to be an expert in his programming language, be it C++, Java, Python, JavaScript, whatever. So he has to know all the details of the coding language, all the subtleties, and so on. He has to be able to, of course, work with large code bases and consider principles like design patterns, extensibility, modularity, and so on. He has to be able to use third-party software or third-party licenses, if that's the case, and of course respect any coding rules or guidelines or even apply, let's say, advanced methods like static code analysis, QAC, and so on, and of course have good debugging skills. So he has to be a very good programmer and understand how he should write the right code to do a certain thing. But the main difference versus machine learning is that the thing which the code actually does, the action or function which the code performs, is a known function. Let's say, for instance, we want to code a website. What is a website logically? It's basically a set of articles or a set of texts which are basically stored on a database, and you want to show them on screen, probably in a nice scrollable fashion, right? So the thing which is performed is logically easy to understand. It's not easy to implement in code. So writing the right code to do this website is a challenging thing because it has to be extendable, it has to be modular, and so on. But the thing which the code actually performs is relatively simple to understand, right? Even somebody who's not a programmer understands what a website is. It's just a bunch of documents which you show to the user, right? So then I would say that the focus for a classical software developer is to write the right code to perform a known function or action. It's not easy to write the right code, but it's easy to understand what that function should be. Now, how is that different from machine learning? Well, for machine learning, let's say we have the image on the left, which is similar to the image that you saw in the live demo. And we want to get from that image into the semantic segmentation version of it, meaning we want to classify whether each pixel in the image represents the road, colored with red, vehicles with blue, markings with yellow, and probably curbstones with purple. Now, making abstraction of the actual code, how should we do this? How do you do this logically? How do you get from a set of pixels to a set of classification of pixels? Like you want to know what type each pixel is. Is it the car? Is it the road? Or is it the marking? What is it? Now, this logically is not so simple as building a website, right? And this is basically where machine learning comes in, because machine learning basically what it offers is a way for determining this unknown function. How do I get from a normal image into a representation which shows me where I have vehicles, where do I have markings, where do I have curbstones, and so on. Or if you want to take the example that you find online, how do I get from a picture of cats and dogs into a classification which tells me, do I see in this image a cat or a dog, right? And of course, we have the famous branch of machine learning, which is actually deep learning, which simulates or does this, let's say, understanding of the unknown function in a similar way as humans do, using artificial neurons, which basically learn from the images how cars, pedestrians, road markings, and other structures look like. So then if we look at the machine learning developer this time, the software, let's say the focus falls not so much in the beginning on writing the right code to do a certain known function or action, but it falls more on finding what that function should be, or identifying that unknown function. And identifying that unknown function can be done by being an expert in mathematics, algorithmics, statistics, and so on, which show you how do you get to that unknown function, which in the previous example was simple, easy to understand, logical. Here, before going into actual code, you have to understand what that code should do. And after you understood what that code should do, then of course you can go about and write it. With, of course, the same requirements, like you have to have extendable code, modular code, and so on. And I also wanted to mention here two additional things. It's, of course, important for the machine learning developer to also keep in touch with latest developments in state of the art, right? Since there's a lot of work, especially in universities, on state of the art algorithms like for object detection, for semantic segmentation, for classification. You've seen a lot of examples, and it's important to be up to date with this, and of course then deeply understand them in detail and understand how they work. And after you understood how they work, then you have to focus on writing the right code to perform what you just discovered after you understood the algorithm. And now, probably what happens at the moment is that you have a lot of experienced software developers, classical software developers, that do not know machine learning because they had no touch with it, but they are experts at writing the right code. And you probably have a lot of machine learning developers who are very focused on understanding the latest algorithms and understanding the latest, let's say, math concepts and statistics and so on, but they're not very good at writing the perfect code for it, especially given the fact that most of them just write code in Python, right? So then how could we make the best of both worlds? Well, we could, of course, introduce the software developer to the machine learning world, like shift his focus from just understanding coding and basic coding principles into understanding algorithmics, while for the machine learning developer, we should change his focus to understand more the coding part, how we translate into code whatever algorithm was implemented. And what we also propose is that if we pair them together to have one guy which knows the algorithm best and one guy which knows how to translate it into code in the best way, then we get the best of both worlds because they can learn from each other and they can collaborate to create, let's say, an ideal product. And in the future, we expect that we will have, let's say, a hybrid developer or a complete software and machine learning developer, or somebody who knows both the mathematics and the algorithmics and the machine learning part, and also knows how to ideally translate it into whatever code is necessary. Of course, that for us at Bosch means taking original Python code and then translating it probably into C++ or even lower level C. Yeah, basically having the best of both. And we see that it is possible to make the transition in both ways. So if you're a regular software developer, we believe that with the right motivation, you can learn the machine learning part or you can learn the algorithmics part. While if you are a new, let's say, machine learning developer, you can also put more focus on learning coding, for instance. So I expect that in the end, they will be merged closer together. And for those who are already, let's say, chosen to continue on just one path, you will be able to switch your path if you have the right motivation to do it. Yeah. This is basically what I wanted to present. And if you have questions for me, please.
Thank you, Lucian. If you have any questions, where in all this, let's say, diagram, where are the data scientists standing on?
That's a good question. So the data, as we see it, the data scientist part is still the machine learning developer. So like I said here, the data stuff is mostly statistics, understanding what is the right data that you need to have, what data you already have, what new data you need to have, how to filter data, how to make data be homogeneous, similar with one another, easily processable, and so on. So it still falls in this category.
Okay, great. And by machine learning, do you understand someone who writes algorithms or,
yes,
or apply them?
It's a good question. So by what I presented here, we understand somebody who can write the algorithm. Okay.
Because there are few of them. I mean, most of the developers are applying algorithms and not necessarily write it down from zero. That's why I was curious.
It's not, it's in principle, it's almost at no time is it as simple as just we take this algorithm already implemented and we just train it on a bunch of new data and it works. Like Cătălin said before, we have different use cases, we might have to adapt that algorithm to perform a different thing. We have to make it work in a real-time system, meaning we want to simplify it, and if we want to maybe simplify it or make it more efficient, you need to understand how it works, right? So yeah, what I did say here is you need to understand and see what's being done in literature, what others implemented, but then you will need to adapt those things to your use cases. And if you don't understand how they work, you can't do
Okay,
that.
but you will not write a new YOLO object detection?
Yeah, we will.
Yeah?
In some cases, we will.
Okay, great.
Depends.
Okay, great. Good. Thank you, Lucian.
Thank you.
And now let's switch to Max. Okay, and let's see if we have any slides.
Hopefully.
Hopefully. Where's, can you press next? No, on your, no, on that. Okay, let me. Just a second. Yeah, I know.
Last hour, roughly in the last hour, we've heard a lot about the automotive industry and what it takes to develop those highly sophisticated self-driving and automated functions. Of course, we need skilled people, we need to train them, we need the technology available to actually implement and enable the functions we'd like to develop. With Bosch, in our slogan, Invented for Life, we do not only focus on automotive application, but also on any other means of transportation and mobility, all being part of the smart city of the future. So speaking of city, maybe some of you arrived this evening with public transportation, either by bus or by tram or whatever, but I'm most certainly sure that every one of us had to deal with the massive traffic within the city. And I've in front of the tram, And with all those data, of course, well, not to forget the driving course. We used to have the driving course for automotive, for cars, but the driving course for rails is somehow different because we need to detect the individual road tracks and thus derive a driving course out of that. All those data and information is then processed and passed to the radar sensor, where independent of any weather condition, we can detect objects as well, but also the distance between the tram and the objects in front of them. So let's imagine one situation: the video camera captures a pedestrian in front of the tram. We can detect whether it is within the driving course of the tram, and the radar sensor then detects the distance between the object and the tram. And depending now on the speed of the tram, which is the information out of the way control unit, which actually connects to the tram. So with the speed of the tram and the distance to that object, we can trigger different warnings. If we are very slow in the tram, the object is far away, maybe an acoustic signal is just enough to make the driver aware of the fact that there might be an upcoming collision. But if the tram is really fast, the pedestrian is crossing the road, we need to react very fast, and thus might induce an automated emergency brake with the tram. So that's the system as a rough overview. When we wanted to pass that technology from road to rail, well, in the first place, it might sound easier than it actually is because we had to overcome some challenges. First of all the software is written for automotive engineering process, development, standards, and so on. So we had to redo that, keeping in mind that the rail standards are really different compared to those in the automotive industry. So we had to think of new standards and new norms which need to be incorporated, especially from a functional safety perspective. But not only the software, also some, let's say, mechanical physical positions are different when we're thinking of a rail, of a tram compared to a car. So the mounting position of both the radar and the video sensor is completely different. So we do get a new angle, a new perspective on all the objects in front of us. So we need to redo all the image processing stuff as well. The second one is the driving medium, of course, as I explained already, changes from road to rail tracks. And the third one, it's interesting, we might not think of that in the first place, but, well, traffic signs are completely different as well. And they are even country-specific, and in some cases even city-specific. So we need to be able to train our system in a very fast and efficient way. All in all, there's a new perspective, a new application, and a whole lot of new data where we need to use, we are somehow really forced to use state-of-the-art computer vision algorithms, deep learning stuff, to be able to work in an efficient way. To give you a short overview how the system works, we've seen a lot of video with Cătălin already, make it very short. That's a tram approaching a tram stop in Frankfurt. We can see passengers, pedestrians actually in orange. The green shows the rail tracks, and in purple the tram we are approaching currently. So luckily in this situation there was no accident. The driver had just to slow down the tram and approach the tram in front of him. But thinking of that use case only, we can have so many ideas how to further develop the system, like applying an ACC, adaptive cruise control function, to trams, a bird view like we're used to in our cars, and so on. So there are various ideas for upcoming generations of the system. Today this system, as it is distributed more or less worldwide, within 28 cities so far and still growing, with a lot of positive feedback, not only from a commercial perspective because it saves a lot of costs, but also from a feedback perspective when it comes to the drivers. It heavily reduces stress in today's increasingly complex inner city environments. So we had we do have a couple of applications in Romania as well. One successfully installed test system in Bucharest where the driver feedback was the most impressive. They said, yeah, we want to have this because it makes our daily life way easier. The second one, as we speak right now, we're about to set up a test system in Oradea, and it's up and running. And we're planning to have a system in Cluj as well, with some, let's say, next generation models and ideas already equipped. So that was just a rough overview about the tram forward collision warning system. Thanks for your attention, and happy to take questions.
Thank you, Max. So if you have any questions from the audience. So how long took you to move the technology from cars to trams?
So,
or you started initially only for trams, or
no, there was
right?
the idea is present within Bosch for quite a long time. It takes some, let's put it like this, it takes some years to apply it.
Okay, yeah. And can you move it to drones? To drone, to fly?
Maybe, but if there's not so much traffic with drones, I think we do have a different challenge ahead of us. So there's a lot of traffic in inner cities, but not that much with drones yet. But maybe it's a good idea, but the drone need to be able then to carry all this component stuff.
Yeah,
it's very easy with the tram, maybe not that easy with drones.
Yeah, I mean, trams is big, and yeah. Okay, and did you start to use them in Cluj too, or in Bucharest, or to put your systems on?
Well, in Cluj not yet. We are working together with the officials to implement, to actually have one tram as a testing system set up. Both equipped with the current generation we are distributing right now worldwide, and with the next level, next generation system as well, to use it as some kind of testing system nearby us.
Okay, cool. Okay, yeah, we have a question.
Put the system onto them?
At least some kind. With the really old ones, it will not work, that's for sure. But the scalability of the system itself, and from a cost and commercial perspective, is not that huge with the old ones. So we usually stick to the newer ones, where we are able to read with the ray control unit the actual speed of the tram and actually trigger some consequences within the tram as well. So it needs some kind of communication.
But not, I mean, trams are electric, right? So yeah, should be. Okay. Thank you. Thank you, Max. Okay, and our next speaker will be online. There might be some challenges to get him online today, but we'll try. So let's see the video. Just a second. Alex, by any chance, can you hear us? Let's see if we have Alex somewhere. Okay. Okay, just a second. 1 second, sorry. Alex, salut. Okay, so we have Alex, just a second. Alex, can you hear us? No? Okay, that might be an issue. Okay, Alex, can you hear us?
Hello, yes.
Okay, perfect. So let me see. Okay, so you have the next and previous buttons. We can see you, hear you. Stage is yours.
That's great. Hello, everyone.
Yeah, we can hear you and see you very well.
Okay, that's great. All right. So,
Sorry, I was playing. Just you can. I'll fix it. Just a second.
that is augmented reality, XR, and so on. So yet another layer. Then there is the very historical, useful layer of mapping the environment. That is topographic maps, also with the extension towards HD maps. We have live traffic data hubs, which exchange data with the cars and with the central systems. We have geofencing maps. So a lot of nuances here in terms of, let's say, the semantics that are involved, and a lot of course, of engineering behind it. And the last, let's say, facet of it are, of course, the topics of really ADS architecture. And that is, I would mention just a few of them. You as experts, you know that there are so many others, but I would mention just maybe drive-by-wire is one of them. It's the CACC, that is the Intervehicular Communication for Cooperation, or ACC. It's about the reprogrammable modules with any autonomous system with the over-the-air updates. So you cannot just let something out there on the street or in the customer's hands, but you need, from a vendor point of view, always need to provide OTA update systems, and to build those modules and to really architect them is a really interesting challenge. It's about how you homogenize the standards, because you cannot afford to be a let's say, an individual implementer which doesn't follow all these standards to integrate in a smart city, for instance. And yeah, so many levels, which is why the article actually is called a recipe for mixing engineering, AI, math, human behavior analysis. It's like a mix of it. So that is basically a short snippet what we're seeing here from the actual article. Put it in a few words. In the article, of course, there's more, a little bit more details on each of these topics. Now,
okay. Okay. So you continue, Alex?
Yes.
Okay.
Shall I try to speed up a little bit?
That's fine. No. Well, we still have
Probably.
5
Yeah.
minutes.
Okay. So then, anyways, the point is that, as I said, I really tried to convey this message that nothing is new, and as you have engineers there and really architects that are thinking about the systems which go in depth, I wanted to make sure that I explain why we did this zoom out, just to see the facets of this topic. So another point in the article for our readers is basically to explain a little bit more in depth that basically we want to build a few things when we speak about ADS. And one thing is awareness, the awareness of the systems in terms of its environment. And basically that we start with perception. And of course, I've mentioned the LiDAR, the radar, the cameras, the stereo cameras. You've talked about the 360 degrees systems, which are upcoming now. The LiDAR is very important because it comes with Kersey, and then combined with fusing, and this is why I said fusing is very important. Fusing of sensor data with GPS data, with LiDAR, ultrasonic, that builds a positioning, pinpoints the positioning up to 10 centimeters. So basically you can have parking and automating this kind of precision actions, which you normally have a human to do it. And then the other thing after perception is, of course, the awareness part and the awareness of the road. Now, I think here I just wanted to point out a few things, like there's semantic SLAM, which focuses on the geometry, so on the semantics of the surface markings, as you talked about smart cities with specific markings on the road and side roads, and about the fact that this is called, basically, it's part of the semantic SLAM algorithm. And also in the past, where vendors are trying to integrate old methodologies like monocular semantic online mapping with semantic SLAM. So it's basically bringing all technologies monocular with the newer one, which are stereo cameras. There's yet another thing that is actually the driving or the action. I called it driving because mostly the article speaks about cars, but it's all in ADS. It's about acting, generally speaking, because you can have ADS in an airplane or in an industrial environment where you don't actually drive something. So, anyways, let's just jump straight into the last part of the very summary, and that is basically to mention a few things that are happening in the market, because this was the last focus of what I was trying to build together, which is something as an intro in the topic. And it's interesting to see some vendor names and some of their products here. And what I would mention, of course, are the let me remember a bit. So the IQ Ultra, so a SoC system by Mobileye, which you definitely know about. It's the in the center of CES 2022, and just with the smartphones, they also rely on the throughput of TOPS based on the small nanometers build up. And of course, NVIDIA becomes a very big player here. Not a surprise with its DPUs, the data processing units, and of course the latest Grace CPU, which also NVIDIA launched, an ARM-based processor. And yeah, also in the last part of the article, you'll read about Tesla, who launched Dojo, the supercomputing training platform, and some other things from Intel, like MoveIt and REM Strength. So conclusion is that I didn't go too much into engineering details. I'm a software architecture by nature, so I'm trying to look from a high-level perspective on the topics, but there's a lot of details in the support documents and the bibliography in the end of the article. So yeah, that's pretty much in a nutshell what's the content.
Sorry, can you hear me?
Yeah.
Okay. Yeah, thanks, Alex, for this. I think it was very, very wide, the spectrum. Did you try to do any prototypes or stuff like this?
Actually, we are working on something, but not for a commercial or consumer application. We are working for one of our customer who is actually in the manufacturing execution lines for cars. So for the Volkswagen Group, all the cars, right? And when you go in a factory today, the big parts of a car, they are not moved by people; they are moved by machines, and those machines act pretty much with a good level of autonomy based on the paths and on some cameras. So we work on such systems to make sure that we collect data from the sensors, we send it to the MES system, send it back to the device. So yeah, it's an ongoing project and very interesting.
Nice, very, very interesting. Okay, let's see if you have any questions from the audience. There were some, yeah, I think we are fine. There was a small issue technically, and they could see only your slides, not necessarily you. But that's fine. I can see you now. You are real. Okay.
From home,
and
yes.
just hear you. Okay, Alex. Thank you very much, and hopefully next time we will see you in Cluj.
Yeah, definitely.
Okay. Bye.
Thank you for the invite.
Thank you. Yeah. We have a room full of people, so I will show you after the pictures. Okay. Let me close myself and let's see if going next. Okay, so just it's my habit to present you about IT Day, so I cannot stop you. So basically, you might know it's the 10th edition of the event, and will take place in Cluj Innovation Park in person finally. So we'll have like 600 or 700 software developers there. It will take 2 days, 4 tracks, and so on. A few of the speakers, we have Wojciech, he's from Amazon. He was at the developers. He will start the event. Then we can continue with Andrei Neguțiu from RWS. He will talk about how we can load big JSON files in memory and to not get out of memory, actually to use half of it only. Then Cornel Ștefănache will talk about machine learning, about politics and how we can, make them more real. Sergiu from UiPath will talk about UiPath applications, of course. What else? We'll have Mircea Vădan, and he will talk about the startup ecosystem. Then Terezia Neagu, she will talk about product management. Călin will be on the hands-on lab. He will talk about things he's done in his house for automation, including some PLC he writes by himself. Then we'll have a panel with Mike Butcher, where will participate Daniel Tămaș, who's the owner of WAMAP, and there will be some more, like, we'll see. Lucian Alexandru, he will be on the IoT side. He will do some sensor stuff, and also there will be there will be a lot of speakers. In the second day will be more or less the same. So we'll start with Peter Leeson. Oh, okay. So this is the first day too. So we'll have also Simona Bonghez, Daniel Suciu, and hopefully at the end will be a nice concert, like we'll have at the developers. In the second day we'll have Peter Leeson. There will be remotely Robert C. Martin, Uncle Bob. So he will have like half an hour presentation and then half an hour Q&A from the audience. And yeah, Peter Leeson, we hope he will come in person. If not, it will be remote, unfortunately. And a lot of other presentation. There will be also some about art, about UX, and HR management, all these kind of subjects will be covered. There will be like 50 or 60 speakers in total. So if you want to participate, you get full access to the conference, or if you cannot come, there will be some online streaming like it was today here. We will have a lot of partners already, and there will be more like, I think, Accessa and probably MSG, we'll see. Yeah, so that's all. Thank you. Okay, and now let's go to the panel, if you don't have any other questions. Okay, so you saw Cătălin. Let's do a tour. So Cătălin is here. Then we have. Okay. Yeah, that was working before. Let me see. Okay, so let me then introduce to you by hand. So we have Cătălin Golban. You see, Ovidiu Popa, he's head of consulting at P3 Services. Hello, Ovidiu. And we have Călin Marinaș, who's division manager at MSG Systems. Just a second to somehow change the camera. Okay. So we only. Yep. Okay, let's start with a small introduction. So, Călin, if you want to say a few words about you and what you are doing.
Sure. So my name is Călin Golban. I work at MSG Systems Romania for about 12 years now. I was part of projects as a developer in SAP projects, and for about 5 years I switched to the management part of MSG of Automotive, and I was a business unit manager, and now I am the division manager of MSG Systems Romania for the Automotive department.
Makes sense. Ovidiu?
Yes, hello. As I said, my name is Ovidiu Popa. I am now consulting engineer for automotive industry. My background is automotive, and I have experience in project management, agile development, or waterfall development. Now I am also in the management area. I am a department lead for our consulting in Cluj, and we are in the point to grow a team for the automotive consulting in process in product compliance, but not just that one. Also other areas, other industry as aerospace or financial.
Oh, interesting. You have also cybersecurity, I think, included.
Yes,
right?
of course. Yeah, that's also a big point in this consulting area, the cybersecurity. Or of course, we discuss a lot about autonomous driving. That's also a big point in our focus.
Also, you do also autonomous driving?
Yes, but we are doing in the high-level development. We are doing the process support for the main players on the market. For example, process compliance, regulations checks, assessments for the teams that are developing the autonomous driving, or we have also teams that are more experienced in the technical area for technical solutions, and we are able to provide also their solutions and support.
Interesting. Okay. Good. Cătălin, if you want to say, I mean, every time I need
Cătălin Golban, responsible for technology development in Bosch Engineering Center Cluj, focus on automated driving, computer vision, cloud software development, especially data engineering. So a lot of things that have to do with technology for automated driving.
Okay, great. So let's start with Călin. Can you tell us a little bit about your projects and what you are doing at MSG?
With pleasure. So maybe I would start by saying that the automotive department in MSG has around 900 people, and of those 900, almost or more than 250 are located in Cluj and Târgu Mureș. We offer a wide variety of projects. That means we cover not only automated driving, but also the production planning before. We cover also sales and marketing projects. We have also quality projects. There are also projects that help our customers to respect regulations that take place. For example, we all know WLTP, the new emission standard. We worked on a few clients of ours and we helped them implement the calculus modus for the emissions. So if you open their sites and you see there the values, most probably they were calculated using our or the software that we developed here. Of course, we have also autonomous driving projects. And what do we do there? For one of our customers, they have a cloud system using Microsoft Azure, and the sensors of their cars are sending them data in that cloud. Lots of sensors, lots of data, a lot of performance issues. Then this data is analyzed and consumed by consumers of this car manufacturer, for example. But also, I don't know, maybe I will let you talk.
And what kind of sensors do you work, or how it's?
It's not. They are not our sensors.
Mm-hmm.
They are the sensors of the car made by our customers.
Oh, I see. So and you do the platform of communicating and all the processing?
Yeah, we do it more generically, so they can send us data. It's not only one type of sensor.
Ah, okay. And you can reuse it for different...
Exactly. Reuse for different projects. Kinds of sensors, and different kind of consumers can consume the data.
Okay.
That is analyzed.
Good. Ovidiu, I know you are doing the dashboard and all this kind of stuff, right?
Yeah, that's a big part for the P3 Cluj. We are doing the development for Android Automotive for some customers. We are specialized in Cluj in this area. We have a lot of developers, I think approximately 120 are just in this domain. But yeah, that's a main focus just for Cluj. But if we take in consideration the entire P3 group, we have a lot of expertise areas, not just that one. For example, we have also in Cluj smart homes development. Now we are trying to grow a team for embedded development, embedded testing and embedded development. That's also for main OEM players in Europe, or yes, also in other zones of the planet. Yeah, that's true.
I see. Okay. So basically here you do Android, Automotive.
Yeah, that's in Cluj. The development for this, it's.
And you are doing it as a mobile or just for Automotive?
As far as I know, yes, just Automotive Android development, yes. And we are customizing solutions for the customers. We are integrate the solutions with the platforms.
I know you will do the thing with the Renault, the new.
Yeah, that's true.
E-Tech.
It's one of the main customers for us. One is Renault, and yeah, for them we are customizing their needs in Android, and we are implementing the features that they are need for the cars.
Nice. Okay, Cătălin, I know if maybe you want to say something about more generically about.
Maybe to point this. So we see that automotive it's too narrow, and if you speak about software, then it extends much more. It extends above what's in the car, and we have examples already here. And for sure, we also what we do in Engineering Center Cluj, we have now more than 1,300 colleagues. They are all doing automotive in this larger scope, like mobility solutions. And a big part of them are doing software development, not only like embedded, also embedded, it's a big part. But if I look at some projects, actually we need more cloud software development, more DevOps and such profiles than embedded C software development, which used, I mean, if some years ago, it was more about embedded C, but now it really goes beyond what's
the next level
software in the car. And I'm a bit fascinated now, so I started mobile software development 10 years ago, maybe more with Java Mobile and so on, and Android appears on the way. Now we have Android Auto and such things, and it's really that the car, it's more and more software defined. And sometimes technologies, frameworks that were evolving over the years are also finding their way in the car, operating systems and such things. Everything was proprietary until now.
Yeah, I mean, I just think,
now we see that it's more also going into the automotive business, and I have more such examples. So I really back some years ago when we've seen these operating systems for mobile phones, because before that everything was closed. It's kind of similar transformation that happens now in automotive. Different flavors, but there are similarities. At least I can see. If I zoom out a bit, by the way, I like the presentation from Alex, I think was the name.
Alex, yeah, Alex.
To zoom out, yeah, very good hint. So I think, yeah, there is some kind of transformation, and we've seen similar transformations that in other industries before.
Okay, so do you think we'll have like to choose between one operating system or the other and just reboot your car and do an upgrade, or, I don't know, change the system?
Actually, I would like to have that for my mobile phone, but still it's not there for some reasons. In the past, we used to have some Linux for these Nokia and something devices, and you could take Symbian or Linux, Maemo, yeah. And I would still like to see that more at hand for mobile phones. And
still, I mean,
next step is for the car, but yeah, configurable, yes, personalized, yes, but changing the operating system is not a user thing. It's more a software programmer, whatever topic. You would do it, I would do it, but I'm not sure if everyone would do it.
Yeah. Maybe do you want to comment if?
And for this part also is very important, the safety and the security for the cars. It's pretty easy to implement things, or it's not easy for sure, but it's easier to implement for a system operator. But if you are taking consideration to adapt to others, then the safety and the security will be exploded.
Well, depends if you move, for example, to Android or iOS, right? And we'll just consider the car processing like, I don't know, external GPU, and somehow if, there will be some processing inside of the phone instead of the car. Maybe.
Yeah, from the development point of view, yes, but the process to assess the product at the end and to be sure that everything is compliant to rules and to standards, it's much bigger than we are discussing now. Behind the entire development, it's a huge process to be sure that the people are safe and the cars are on the safe side.
No, I agree. I mean, yeah, they can test.
Just the software update takes very much time and a lot of efforts. Software update management system, it's a big topic in the industry, and it's very good regulated. And to change the operating system could be much harder than just an update.
Yeah. Cătălin, what do you think?
Everything you said, I find it's correct. And maybe when changing an operating system, you can create bugs that you didn't know they existed there. And leaving the security aside, which is, of course, extremely important, also the user experience is really important. So if you input you put some faulty software into the car because you cannot test everything, especially on older cars, you get a poor user experience. Nobody will buy those cars anymore. So I think,
it's more for software developers, maybe. Yeah. But that would be cool. I mean, it would be nice to have my own app or my own operating system inside of the car, even if you'll be on your own risk.
We can keep the agile mindset and we try to adapt the processes and everything behind, but it takes a bit longer than in the normal development or in the common development, software development.
Oh, yeah, I agree. And how do you see in the latest year the Cluj ecosystem is considering the automotive industry? How do you? I mean, from my perspective, it's growing and we are accumulating more and more knowledge.
Maybe I'll start here. I think it's growing. I think we can do much more complex things that we did maybe 5 or 10 years ago. We get an input of a lot of new and young colleagues that learn very fast, that come much better prepared from the universities, And I think, this adds a lot of value and possibilities, and we will have a few more years of growth in front of us. We will make even more complex things.
Yeah, I think it depends also how you stimulate. I know you guys, you have those nice challenge like autonomous
Bosch Future Mobility.
Bosch Future Mobility, which is, I don't know if you saw it. So all the participants get some cool, nice car, and they can customize them and write software for them. And then the challenge is to go on a let's say a toy trip. But there are the challenges are coming from, let's say, how the sun is, the light of the sun is there, because, and you know how the environment is, because due to this, not all the cars will be calibrated, as far as I saw last time, to the environment. So if it's working at home, might not work here, or you know. Cătălin, if you want to say.
I'm shaking my hands because I have a colleague who has some really tough times in working with a customer for these calibration-related topics really before the start of production. Cannot give details, but it's really a topic, and it's a challenge to have these automatic calibrations happening and working there in the background, keeping the systems running stable. But to your question regarding the automotive industry in Cluj ecosystem and so on, I think it's definitely progressing. Again, if I look to 10 years ago when mainly we were doing web development, backend, mobile and so on, now it's really also a lot of automotive business, and I think it's some gradually kind of transformation of the local industry. So I think there is still a lot of potential. So we see in general that automotive business is growing, even if the number of cars are that are produced per year, it's a bit decreasing. The technology that we have in the cars, it's increasing, and the business around the technology, it's bigger and bigger, including the software development technology. And then I think we can build a lot still on top of the existing software development experience that is accumulated here locally. And we had some examples. Cloud software, it's very strongly linked to automotive, and now it's automotive software, even if the same stack of technologies would be very much applicable to other industries.
Okay, so to take from automotive,
to take experience from non-automotive to bring it in automotive, for sure, for such domains, it's a longer experience that people have in banking or other fields that are here around. Mm-hmm. But there are some big players now also, and I think it's developing. University, adjusting curriculums, doing more, feeling a bit also the physics, the dynamics and so on of the car. It's important. For me, for example, it's fascinating to see, I'm more a software guy, but if I look at what other colleagues are doing, not necessarily my department, but for example, we had Jens, he has a department that develops, the colleague that presented initially, they develop a steering system that has hardware, has mechanical engineering, and also have some software, which is really a core part, because that software controls the direction of the car. And they do it here.
On the steering.
On the steering, and it's a lot of, it's really interesting. So to have this all levels, not only software, but also underlying hardware and hardware components and SoCs and MCUs and so on. So different hardware components that are running the software, and also then the mechanics behind and mechanical engineering, and to design all that and to put everything in one big product. So I think that's also interesting. And the potential for automotive here, it's beyond purely the software part. It's more, it's going towards hardware and to mechanical engineering, so to have the whole package.
Agree. It makes sense. Cătălin, what technology do you use? Because I know Ovidiu is on the Android, but what about your teams?
Most of our colleagues develop using Java technologies or JavaScript based frameworks on the front end. We also have a number of about 50 colleagues that develop using SAP technologies. Okay. Of course, we have cloud. We have projects that use Azure. We have projects that use Amazon Web Services in the back end, Spring and every.
I see.
Yeah,
but not necessarily low level, but just high level and coordination.
At this moment, we don't do low-level programming. Who knows, in the future. We are not excluding it.
Okay. Ovidiu, except Android, what you are doing more as a or at least from Android Automotive, I guess, right? And
Yes,
I'm not sure if there are any frameworks or something special or different.
For Android, I can't clarify very much in detail, but what we are trying now to build the knowledge in C++ and also in Python for the automation testing. This point is very, very it's very important to be clarified that it's ongoing. It's not just Android. We have a lot of embedded too, but in Cluj we are growing in this direction. We don't have so much experience for the moment, but now that's the point where we are trying to get more and more experience.
Okay. Cătălin, I think on your side you go from the C++, C.
I could say everything. So
I mean that.
But imagine it's hard for me now to discuss about what technologies are using 1,000 something people. So. For sure, C++ it's a key programming language when it comes to developing something embedded, and that's clear. But then, if we look at like beyond embedded, then it comes with all the Java-based or Microsoft.NET-based technologies. My personal opinion is that it's a good asset if you, as a software developer, have some Python knowledge. It's not that difficult if you've learned some other languages.
Especially for machine learning, right?
Just a hobby, 3 days when you have less work to do, and you already started another 3 days and you're mid-level, whatever. So I think it's good to have some Python software development experience, and it's a language at hand. And then, of course, with each language, a lot of technologies come, and it's a matter of looking from an architectural point of view, what is the capability, what it makes sense, why using this or that message queue or streaming processing or persistence database and so on. So I think it's when it comes to technologies, it's really, you need to not only understand it as user, but as from design principle, what is good at and so on.
Having so many people, how do you do the technology transfer? I mean, if someone new comes, do you have like a knowledge database there where everyone is looking, or how, or it's project by project? Because I think there's a big ramp up to speed up with the rest of the team for
I mean, we take the time. It's important to take the time for, for example, in the computer vision area, ramp up takes up to 6 months. And then colleagues are learning what we have, what are the still remaining problems, what we want to do in the future, which methods. So it's really a big learning process, and it makes sense to take the time initially to learn, to create a big overview so that you work with some kind of level of autonomy afterwards.
Okay.
But it very much depends from project to project. We have smaller projects where you need a proof of concept, a prototype, and it's purely for a customer demonstration, and we do it in a more fast lane style. And then when it comes to making a series product out of it, then we need to take the time to look at all the decisions and also develop to certain level of standards that you were also mentioning.
Okay. How about you? How in your place? How you do the ramping up for the new guys?
For the new guys?
Yes.
Oh, that's a good question. So most of our colleagues come from the universities. I think, yeah, maybe. For example, this year we had almost 50 interns in our programs. They will be joining our projects. They will have some mentors that will guide them, and of course, learning by doing a lot. Also, the mentors will guide their learning and learn the technologies that we need in, first of all, in our projects and afterwards in the whole company. And of course, learning is a process that never stops. It's an ongoing process.
Okay. Ovidiu, if you want to comment, or I can ask
Yes,
you another
of course.
question.
For us, it's a bit different depending on the department where we are discussing. For the development department, of course, we have the ramp-up phase, and that's clear. It's a process defined, and we take the time to grow the knowledge and to give the necessary knowledge for the day-by-day work. And for example, for the consulting department, we are working with experienced colleagues, with senior colleagues, and for this it's much easier because they have already experience in the ramp-up phase, and also the seniority level as employee help us a lot to reduce this time a lot for the ramp-up.
I see. Okay. And by the way, if you have any question from the audience, please just raise your hand. We might try to do it more open discussion then. Okay, so we have a question there. If Christina will give you a mic. Ah, okay.
I can also speak English. Not sure if I'm matching the topic, but I was thinking with the Bosch software, if it's possible to make some configuration as an end user. Let's say now that I'm an owner of the car where Bosch has the software, would I be able to do some of my own configuration plugins or something like that to, let's say, the dashboard displaying something in a different color, displaying some stats that I want to have?
So definitely, when it comes to the software that we develop for dash units, which we don't do in Engineering Center Cluj, they should have some certain level of configurability, because in the end we don't really do what we want. We work according to some OEM customer expectations. So very often the UX comes more not from our UX guys, but more from the OEM UX guys. What I think is interesting is that we start to see more and more situations where the software that we have on some ECUs in the car is not coming from one single supplier. And probably for instrument clusters and so on, that's more longer because it's not necessarily safety critical, but we see this kind of trend for every ECU, every vehicle computer, every CPU, processor, whatever, SoC that we have there in the car. So it's more like more companies, more businesses develop their technology, and in the end someone integrates it together. So would not be like you as end user, but would be maybe some smaller company that develops a small part of it. I think it's a diversification that we also see when it comes to doing business in automotive now.
Sorry for the interruption. Okay. I wanted to ask you what you think about electrification and how much do you think it's important due to the in parallel with autonomous driving. It's a must to have electric driving systems for autonomous driving, or we can adapt with what we have? I mean,
so it's not a must, but the situation is that we need to do this transformation from other reasoning, and I'm not an expert on that, but definitely like the two systems will coexist for a while, the diesel and all the gasoline and so on. Powertrains will decrease and will go lower and lower, and the electrified with different technologies, including hydrogen, maybe will increase as a propulsion technology, and the industry goes towards that. Of course, we adapt and we shape this as much as possible. By the way, we also have projects regarding electrification, and the one that I like most is they call it battery in the cloud. So all the speaking about cloud, all these ECUs in the car, they tend to have a twin in the cloud, and then battery also has it, and it's a piece of software that is analyzing the data. It's making different correlations from more vehicles with the temperature outside, so at which how many degrees are outside when the engine is running, and how much voltage it takes, and so on. And then it makes some kind of precise forecast on how long the battery will take, how to optimize, when to charge if possible, so that you don't drain it fully and then use it fully, and so on. So these kind of add-ons that it's like quite a smart idea. I started like that, and then it develops towards a successful business with value added in the bigger context of electrification. Just wanted to give you an example, because I recently exchanged with one of the colleagues from another department that are working exactly on this.
Right, and they can know where maybe there's more growth and needs for electrical cars, chargers.
Yeah. Or another use case is that now we very carefully look at the mileage, and so the charging, draining, charging, and so on. There is these cycles that are kind of degrading the quality of the battery, and then when you buy an old car, you don't know, okay, how was the battery used and in which conditions and so on, and then you have some kind of proven certificate which shows what is the quality of that battery, for example. It's a similar use case.
Yeah, agree. If you want to comment, what I'll expect in the future with electrical cars, that we'll not necessarily own anymore too many cars, but we'll just rent them as we need it. I think that will be a better model, because otherwise it's kind of complicated with a car where, after 10 years you need to change it, or I don't know, to kill it and take another one, because might not work the battery, right? And make no sense to change it.
Yeah, also ride sharing, it's a trend.
Right, that probably.
So funnily, some years ago, I thought I would never, there was some company where you can drop the car and then take it from wherever. I don't remember the name, but some years ago,
Pony cars.
I thought, okay, I would never take such a car because I have my own car and I'm driving it. But now, actually, sometimes I take a taxi because it's you go in the city center, then you need to move around for half an hour to find a slot and so on. So it's much more convenient to use it. And I guess in the same way it would work with some fleet of automated cars driving in a very well defined area. Yeah, so why not? Of course, comes together with automation, electrification, and
yeah, because in a city, I think you don't actually need a car. You have public transportation, you can have a bike, you can have whatever. If like Cluj.
That's true. Yeah, you have alternatives, but we are used to use it to have the car in the city, and it takes a while.
Exactly, but if you not have where to park it, then it will make no sense. I don't know if you want to comment.
Also, in the development process, MaaS and TaaS, Mobility as a Service and Transportation as a Service, a big part and a big player in the development. We have to take in consideration this to adapt our product and our solutions for this kind of usability.
Exactly. Yeah, I mean, you need to design it with the idea that might be shared or something like this.
That's
right?
definitely in the development process, and it's involved in the architecture and in the product at the end.
I remember a few years ago, I think the guys from PTech were doing something like this. So instead of buying one car, there were like 5 people buying the car, and then this negotiate when will you be used by each of them. So I think this was on France or something.
Yeah, but if I think about myself right now, I don't think we're there yet. You need a larger number of cars that you can share, because you said about Get Pony, that's the way they were called. You had a limit where you could park that car. Maybe sometimes you had to walk 1 mile to the next available car to get
it was not feasible, but I remember this year or last year I wanted to rent. I don't know why I wanted to rent, and I discovered, okay, there are no any in the city. But yeah, actually I used them when I was without a car for some reason. So
I used Get Pony also.
Yeah.
I think the pandemic didn't help them a lot.
Right. Yeah. But at the end, I think will be some kind of sharing. Yeah. Okay.
So, anyway, what's clear is that this car sharing, it's a trend. It was there before the pandemic situation. Now somehow it decreased as views, but I guess it's coming back. So it will be one of the mega trends, maybe to call it so, in the mobility.
If you are talking about automotive and electric car, how do you see the future of charging? I mean, because it's not working like it is today, right? You need to find a socket, and if you are living not in the standalone house, it will be difficult. So how do you see this issue of charging, if it will be fixed in the future or not?
So just a citizen perspective, I think if the need is there, then the number of charging stations will also pop up. So I don't think it will be a challenge to put more charging stations. But again, I have no idea about how
I was thinking more,
works.
maybe we can get, inducted energy from the road, and this will be easier to charge, right? Just go with the car somewhere and we'll be charging in half an hour or something.
From my point of view, for the moment, the main issue is, the main challenge is the infrastructure that we have, how we produce the electricity, how we can distribute it in the city. And of course, if you take in consideration the place where we live, we have to have a lot of chargers if we will move on this one.
It will not work. I don't think we'll have 200,000 chargers in Cluj, never.
Chargers and electricity capacity we don't have for the moment, but of course it's another topic, and it's an entire industry that is taking care of that. And for example, now we are seeing a lot of projects from the EU that are trying to build the power outside from the city, and to provide, for example, with green energy, to provide the power that is needed. That's, of course, a big topic and will be a huge challenge in the future if you are continuing on this solution. But now we are continuing on that.
Yeah, I'm curious what will happen. Or we'll go to the hydrogen. But with hydrogen there are other issues.
I'm pretty sure it will be actually a mix of energies that will drive our car. Maybe we'll have some electric cars for short distance. Maybe we'll have some hydrogen cars for long distance. Because I'm not really sure that we will be able in the near future to have that much energy for if we replaced all the cars that are existing now with electric cars.
Yeah, the problem with the hydrogen, as I understood, is that you cannot keep it. So if you put it in a storage, it will go out because it's just one hydrogen, right? And we'll go to the other molecule, and I don't know in how much time we just have half of it if you not use it right away.
Maybe I'm wrong, but I think the real problem with hydrogen is the temperature, because it needs to be kept at minus 170 degrees or so.
In order to keep it, in the storage.
And that's the problem, from what I understand. But I've seen some articles in the last few weeks about trains that drive on fuel cells and hydrogen fuel cells, and they seem to work quite fine. They are now making ranges for about 1,000 kilometers. So maybe also that will be a solution.
Oh, okay, yeah, for trains. Good. Okay. How do you see the evolution of Cluj automotive industry? How will it be in 5 or 10 years from now?
With much more experience.
Yeah, do you think we start develop also the hardware here? Because right now we do the software mainly.
We have already hardware development for the automotive industry.
But not so known as the software industry, right, in automotive.
Yeah,
I mean, I don't know how much hardware we do here.
We have, for sure, we have some companies that are doing hardware development. Also Bosch, it's a big example. But yeah, it's not because we are discussing IT stuff. But if you are discussing about the development from CAD development or for development as parts, it's for sure also a player, not the biggest in the Romania, but it's a player, Cluj, for hardware development.
Cătălin, how do you see this hardware stuff?
So definitely we have hardware, so we have a big department doing hardware development. I was showing the vehicle computers. Colleagues from Jucu are actually designing
the production, yes.
What goes into such a box, what kind of chips from each supplier, so what it's in-house and so on.
But are the chips made here, like designed here, or?
I mean, it always depends on which level of granularity we look at. Some of them, yes. And we also produce those, so it's we have some production lines, and it's not only developing but producing. But moving to your question about automotive industry and future, I think this will very much reflect the trends that are happening in the automotive industry in general. So like this connectivity, electrification, automation, and so on. And then specifically, I think this growing expertise will also bring some growing responsibilities, meaning full projects here. For me, as a full project, I understand like the whole package, taking the development of the hardware, the software that runs on it, the sales organization to distribute and to make the whole business. So really big projects with some hundreds, maybe 1,000 people involved end-to-end in it that are developing everything fully here. And I think we should aim for that. Yeah. So that's one thing. And then it's also the technology part. So I very much believe on what we can do on top of what software development local community already knows. And it's a lot of stuff. And see the presentation from Lucian, he was kind of exemplifying what's the difference between an AI software developer and machine learning software developer. With a software developer, you add a bit on top, some motivation, and then you are kind of moving upskilling or whatever we want to call it. So I think it's also this kind of transformation that will happen to extend, to progress, to change, to improve our skills as competencies towards like the new technologies that are coming.
Okay. Cătălin, if you want to comment.
Yeah, I will have to go with software.
Okay.
I think we'll do furthermore software also in 5 years. But exactly as Cătălin said, I think we will get to cover a larger area. We will have software that will be developed here that will be in contact with the clients directly. We will negotiate, we will also make sure, or we will do the maintenance for that software after its delivery. So the full DevOps things, or maybe quite biz DevOps, also the business part of the project before the developing and the operations part.
One more question, maybe to Cătălin. So Cătălin, you develop more or less autonomous driving car, right? If a car drives by itself, well, probably for shorter distance you thought or you have been, right? What's the feeling of someone sitting there? I mean, do you like it, or is something that you need to accommodate, or at least for you as a human, if it's driving by itself on the street? How you see it?
Short answer, you're getting used with it.
Okay.
and you start to like it.
Okay.
Same as you like now the parking assistance sensors, same as you like maybe the adaptive cruise control, the steering or emergency lane, which are there, and you like it.
Oh, I see. Okay.
Yeah. First time my experience with that, so I experienced automatic emergency braking 9 years
Okay,
ago
that's normal.
when I
Okay,
started
yeah.
at Bosch, and it was okay. Let's have some fun. And so, okay, I see the benefit, not hitting these dummy pedestrians that are crossing in front. So then second time I experienced some 1-2 years later automated driving on a highway, fully based on maps. It was a kind of prototype system. They had a precise map, and I was, okay, we want to do some projects together. Let us show you what we actually have now. And it was like a system purely based on maps that was driving automatically. We were very close to an accident, so it was like 3 lanes. We were on the fast lane. There was some other guy on the first lane, and we also, our car, which was driving automatically, wanted to steer towards the middle lane and the other. This is kind of dangerous scenarios.
So
this is why we need 360 and not only maps, for example. Yeah.
Oh, interesting.
But I think you are getting used with it, and it's same as the most difficult part is when you have something and then it's taken out from you. And
yeah, that's usually
you can think differently. Yeah.
Yeah, that's why usually you need to take care if you want to give a raise to someone. You cannot take it back.
Yeah, good point, yeah.
Yeah. Guys, so what do you think, Călin, what do you think about, so the next step, in my opinion, will be to move maybe to something that is flying. It's flying like drones. And probably I like more to fly the car than to have the autonomous driving. Maybe, I'm not sure. I didn't try. What do you think about this flying perspective?
I don't think that we will see flying cars in the next, let's say, 15 years. It will be extremely difficult to regulate or to. You have no rules, you have no lanes, you have nothing. It will be a lot more difficult to control the whole
can
traffic.
put some augmented reality in your glasses maybe, and you will see them. I mean, yeah, you can.
I enjoy flying, so I hope one day I will get to try this, but I'm pretty sure it's far away now.
Yeah.
We are still investing a lot of efforts in doing our cars work better, so that's why I think it will be a while.
Ovidiu, what do you think?
From my perspective, the main challenge was that we are in control now in the flying process, for example, for personal use, for the equipment that we have for the small, for small flying apparatus, we can't do it autonomous. And maybe that can be a good solution because you don't have anymore the issue that it's very dangerous in the personal usage.
Okay. Cătălin, do you think we can adapt this to fly away?
I mean, it's completely different technology. To be honest, I don't know what's the status, but from a different Dubai show or whatever, Shanghai show, some drone that flies pop up from time to time.
They're appearing.
I don't have no exact examples, but I'm pretty sure it was there some years ago. Back then I was thinking, okay, I don't live at the last floor, but there is a neighbor above me, so how I would negotiate with this guy to let me park on top of his apartment. So if such a thing would pop up, no, of course joking, but I think why not? I mean, we have drones, they're flying, it's like smaller weights, it's a matter of scaling. I'm not an expert into that technology, but if it comes, then it will be a matter of legislation and which routes and for what use cases, and is it hobby, is it also some logistic first behind and so on.
Well, probably first will be some autonomous drones for deliveries.
And I would receive again, not the last floor, but the one before, I would receive a pizza from a drone if someone would deliver it to me like that, so no problem. Maybe that comes first, not cars, but logistics.
Yeah, yeah. Yeah, so, or the guys from the last floor will, will buy flying cars, and the guys from, bottom will just regular car. Because they need to charge them, right? So okay. If you don't have any more, we have a question there. Maybe we can get a good microphone.
Is it working? Yeah.
Yes.
Now it's working. In the context of vehicle to everything, I was curious what interesting functionalities Bosch focusing on. As I understood, you gather a lot of data from the cameras 360. I was curious if you can or you do, what's the request on the market? Send kind of information like there are holes in the road that could be patched to send that data to authorities or to make it public in some way, or the waiting time at a red light. What kind of interesting, where is it converging towards, like in this context, if there is any road already there?
So it's a lot about that. By the way, the demo that we were doing, it was via 5G. So we have a partnership with one of the telecom companies, and they enabled us with some dedicated 5G network around. And that was 5G, I mean, less low latency and so on. This is what we are using more for a testing purpose now. But if it comes to using it at full power, due to the small latency, we can imagine car-to-car, car-to-infrastructure and so on communication. And that will enable some use cases like that benefit of this latency. The potholes part maybe would be more, by the way, we have a project called Road Hazards, where we collect such hazards with the cameras, send it to the cloud, aggregate it there, do some kind of map layers on top of it. And also colleagues from my team actually started recently to work on such topics. But what I think it's the key, so the connectivity for in the longer run, it enables features where you as a driver get something like lane keeping or some feature, and you don't know anymore, and you actually don't care anymore where it happens, the computation for it. Is it locally? Is it in the cloud? Is it a combination? It doesn't matter. It starts to be less important for you. Same as now on the smartphone, you have different applications, and you're not sure if the actual data processing and intelligence for getting such a feature is happening locally or in the cloud or both. And I think the same trend will happen in automotive. So it's a lot of features. Smart city, another big topic. So moving the cameras inside the city and doing all kind of statistics about infrastructure, about how many people, where to put new infrastructure, new crosswalks and so on. So it's a lot of unlimited use cases that can be added there. But I think the big part is that from a driver or user of a car point of view, you don't care that much anymore if it happens locally, in the cloud, both. So I think that's the big, beyond the use case from what will happen from technology point of view.
Maybe to the contest, we can, you can do next at some point the drone stuff, but not just the drones directly to drive independent, but to do some kind of transformer. So the car should transform in a flying plane and then to do the circuit. But this can be
actually first we want to go for bigger cars and to have some. I always told the guys that look, this is quite a toy use case. The real development is different, more challenging and so on. So I think a first step would be to go to bigger cars and then to move to other like flying objects and so on.
Yeah.
Just my opinion. Maybe
Yeah, I agree,
Ionuț Munteanu may have
yeah.
some other perspective on this.
Yeah, but I was just thinking that maybe like a hobby project would be cool to start something which is flying and have some sensors there.
So there is a lot of activities with drones regarding making maps, making reference data, scanning infrastructure, and so on.
Mhm.
That's, I think, a big activity.
Okay, good. And I think with this we can finish our nice panel. I enjoy it. I'm not sure if you, but okay. Let's give a round of applause for our guest. Thank you too. I mean, let's stay for socialization and we'll do some discussions here, but we'll stop. Yeah, thank you.